Good morning, students. So in last lecture we have done about the factors affecting the rate of reaction, right? There we have discussed three factors, that is concentration, temperature and catalyst. So discussing one of the factors in detail, that is dependence of rate on concentration. That how does a rate of reaction depends on the concentration. So first of all, we have discussed about the graphical representation of concentration of product with respect to time and concentration of reactant with respect to time, right? Now if we combine both of the graphs in a single pattern, so what we will do, now this is a graph with respect to concentration and time. Now it is a single concentration, it is not for the reactant, it is not for the product, it is for the both, right? So here in concentration we are talking about the combined, that is reactant also and product also. So now let us plot. Now again, at time 0 the reactant is at its highest amount, so again the graph will go on decreasing like this. As the time increases, the concentration of reactant decreases. So this is the graph of reactant, right? Decrease in concentration with respect to time. Now what about the product? So at time 0 the product is also 0, but after some time what will happen, that the product the concentration of product will start to increase. That means from 0 now it is increasing, right? So now this is the graph of the product, or we can say that concentration is increasing with respect to time, right? Now from this graph we can conclude that how the rate of reaction depends upon the concentration. So if we talk about the concentration of reactant, so as the concentration decreases, a time comes when the reaction will get stopped, right? जैसे जैसे reactant का concentration कम हो रहा है, एक time आएगा कि reactant will get finished and the reaction will stop. If one of the reactant will be finished, so what will happen, that the reaction will stop at that point, right? So this means that rate of reaction is directly proportional to concentration of reactant. How we can say this, जैसे जैसे concentration बढ़ेगा तो rate of reaction, जैसे जैसे concentration घटेगा so rate of reaction भी घटेगी, right? और जैसे जैसे concentration बढ़ेगा तो rate of reaction भी बढ़ेगी. Now suppose अगर हमारे पास reactant खत्म हो रहा है and what we will do कि हम उसमें और reactant add कर दें, so what will happen, again the rate of reaction will increase, right? So जैसे जैसे हम concentration में change लेके आएंगे, according to that the rate of reaction will also be decreased or increased. So that means we can write it as rate is directly proportional to the concentration of reactant, right? This square brackets are the concentration and suppose R is here reactant. Now as we have studied in class 11 in chapter equilibrium about the law of mass action. Now what is law of mass action? In law of mass action we have discussed that in any chemical reaction the rate of reaction is directly proportional to the product of the concentration of reactant. Product means if there are more than one reactant, 2, 3, 4, then it will be product of all the reactants. And raised to the power the number of molecules participating in that reactant, right? So again rate is directly proportional to the concentration of reactant raised to the power n. Now this n is the number of molecules taking part in the chemical reaction, right? It can be 0, it can be 1, 2, 3, it can be anything. So this is termed as the rate law, right? This is the rate law expression. Now अब इसको हम और अच्छे से समझते हैं with an example, right? So suppose there is a chemical reaction that AA plus BB will give CC and DD, where small a, b, c and d are the stoichiometric coefficients of the capital A, capital B, capital C and capital D, which are the reactants itself, right? Now how will write the rate of this expression, this reaction? So again rate is directly proportional to, Now directly proportional to the concentration of reactant. Here there are two reactants. One is A and another is B. So it will be concentration of A and concentration of B, as rate depends on the concentration of reactant. So according to law of mass action, what we did, that product of the reactants in the rate expression. Now the number of molecules participating in the reaction. So suppose A has X molecules and B has Y molecules which are taking part in a chemical reaction. Now this X and Y can only be determined experimentally, right? We cannot determine it by theoretically, or we can say only by seeing this reaction. ठीक है, हम रिएक्शन को देख के नहीं पता लगा सकते कि वेदर इट विल बी 1 2 3 और 4. इट कैन ओनली बी डिटरमाइंड एक्सपेरिमेंटली. ओके, नाउ अगर हम ऐसे प्रोपोर्शनैलिटी का साइन हटाएंगे, व्हाट विल हैपन, दैट देयर कम्स एन इक्वल्स टू विद अ प्रोपोर्शनैलिटी कांस्टेंट k, right? And this is concentration of A power x and concentration of B power y, right? Now it can happen that this x and y may or may not be similar to this. Sometimes this A and B will be similar to x and y, right? And what happens sometimes is x and y is different from this stoichiometric coefficient. So it is not necessary that x and y have the values of like this only, right? So this is the dependence of rate of concentration. Suppose we take an example of burning of wood, right? Now burning of wood takes place in the presence of oxygen, right? Now if we burn that wood in air, and suppose if we burn that wood in pure oxygen, so किस हम बोल सकते हैं किस केस में वो वुड क्या होगा, जल्दी बर्न हो जाएगा. सो दैट इज द केस ऑफ प्योर ऑक्सीजन. व्हाई? क्योंकि प्योर ऑक्सीजन में हमारे पास क्या है, कंसंट्रेशन ऑफ रिएक्टेंट, दैट इज द कंसंट्रेशन ऑफ ऑक्सीजन, इज ग्रेटर. उसमें एक रिएक्टेंट की कंसंट्रेशन क्या है, ज्यादा है. एंड इफ यू टॉक अबाउट एयर, सो एयर में देयर इज ओनली 21% ऑफ ऑक्सीजन, or we can say that 1/5 of the oxygen is present in the air. So that means वहां पे जो burning of wood होती है, that process becomes slow, right? So we can also understand from this example that rate always depends upon the concentration of reactants, right? Now this K is termed as rate constant, as this is a rate law expression. This is a rate law expression. So in the rate law expression, this constant is rate constant, right? This is the concentration of A, reactant A, concentration of reactant B, and this X and Y are the molecules which are taking part in the reaction. Okay, so K is the rate constant, and in that rate equation, and X and Y are exponents, may or may not be equal to that stoichiometric coefficient. So I think it is not very clear to you that X and Y can only be determined by the experimental values, right? So now what is rate law? So this is the definition which I have told you, right? So this is an example of a rate law expression, or we can say rate equation. So rate is directly proportional to concentration of reactant raised to some power. Okay, and if we remove this constant sign, then there will be a proportionality constant, and this is our rate constant. Okay, now this rate constant is also named as velocity constant, as this rate constant is a constant for a rate of reaction, right? And rate means speed of a reaction, so it is also termed as velocity constant, right? Now suppose if the reactant which is involved in a chemical reaction, so its concentration is unity, right? Suppose that the concentration of reactant is unity in a given specific reaction. So now if this is 1, unity means 1, so that which means rate of reaction will be equals to rate constant, right? So if the rate of reaction will be equals to rate constant, then This is also named as specific rate constant, right? So three names are given to this constant, that is rate constant, velocity constant and specific rate constant. And specific rate constant, why? That when rate of reaction is equal to the rate, when rate of reaction equals to this, when the concentration of reactant is equals to unit, right? So this is the definition of rate constant, that it is a proportionality constant which relates the concentration of reactant to the rate of reaction, right? Now let us take some of the examples. Now suppose we have given this equation, right? Now when we calculated its rate law expression, and I have already told you that this rate law is only determined experimentally, right? So how we can determine this experimentally? So we can say that if we put one of the reactant concentration constant and change the other concentration, right? Either of the reactant is put constant or can be changed, or we can say that we change both of the reactants concentration, right? So it can be found by any of the way. So after the calculation, experimental calculation of this rate law, what is found that this rate is directly proportional. So it is very obvious that reactants are these two. So it's only depend on this. So concentration of NO. This is concentration, then concentration of O2. Experimentally it was found that this is raised to the power 2 and this is raised to the power 1, right? Now rate is equals to a constant K, NO raised to the power 2 and O2 raised to the power 1. Now in this rate law expression, it can be seen that this exponents are equal to the stoichiometric coefficients, right? It can be seen from here, but not on all the chemical equations it is observed, right? Suppose we talk about this reaction. So this is also balanced reaction. Now rate is directly proportional to again this. So concentration of CHCl3 and concentration of Cl2. Now it is observed that this rate is concentration of CHCl3 raised to power 1 and chlorine raised to the power 1 by 2. Or you can see now here that this chlorine exponent of the chlorine is not resemble with this stoichiometric coefficient. So ये हर बार पॉसिबल नहीं होगा कि ये दोनों क्या होंगे, सिमिलर होंगे. Sometimes it may be equal and sometimes it may not be equal, right? So now rate equals to K and this. Copy this by yourself, okay? This 1 and this Cl2 in power. Now again coming on to this. So now this rate is equals to, or we can say directly proportional to this 2. So that means CH3, COO, C2H5 and H2O. Right? Now it is calculated that this is square bracket, right? It is calculated that this raised to the power 1 and that water is raised to the power 0. And you can see there in this reaction both stoichiometric coefficients are 1. So here also these exponent and these stoichiometric coefficients are not matching with each other, right? So this is the way to write the rate expression. It is determined experimentally. Sometimes it is given to in the question, or there is a hint that how to calculate it, right? Now coming on to next part, that is differential form of rate law, right? Now again consider a reaction that this is the reactant and it will give the product this. Now if we write the rate law expression, so this is the rate law expression. Now we get to know that how to write the rate law. Now we have studied that rate of reaction is the change in concentration per unit time, right? Change in concentration of reactant or change in concentration of product. So with respect to reactant, because we are taking here reactant, so with respect to reactant, it can be written as dR by dt, right? And as this is the concentration of reactant, so this is in square brackets. And reactant concentration always decrease as the reaction proceeds. So here comes a minus sign, right? So this is equals to the rate law expression, right? So only this is the differential form of rate law expression. We have to put the value of rate which we have studied in the introduction part of chemical kinetics. Okay, now this here we enter this topic, that is we have done now rate law expression, this rate constant. Now there is one more thing, that how the rate of reaction and rate constant depend on each other. So as we can see that they are directly proportional. So k की अगर क्वेश्चन में k की जितनी ज्यादा वैल्यू दी है, that means the rate of reaction is very high, and if the value of k is very small, that means the rate of reaction is also very small. Okay, now coming on to the in-text question, or question number 1. Now what is given in the question, that a reactant is converted into product. This is a general reaction. Concentration of reactant is decreased from 0.03 to 0.02 in 25 minutes. It is given. Now what we have to calculate? We have to calculate the average rate, right? Now we have studied the average rate formula, that is rate of reaction, but we are talking about average rate of reaction is equals to del. I have told you that this is for the large time interval. Okay, so del of this reactant upon del T. As the product of concentration is not given, so it is not necessary to calculate that. Average rate is equals to this, and that is equals to product also, right? Because reaction तो एक ही है. So अगर हम reactant का निकाले और product का निकाले, that will be the similar, यानी कि rate of reaction एक ही आएगा, right? Now as this is a reactant, so put a minus sign here. So this is the formula of average rate of reaction. Now put the values. So del R, that means change in concentration of R. This to this. So change कैसे निकालते हैं? Final minus initial. That means 0.02 is the final concentration and 0.03 is the initial concentration, and per unit time. Now in the question it is asked that calculate the average rate with respect to time in minutes also and in seconds also, right? We have to calculate both the units of time. So first of all, put the time in minutes only. So upon 25, right? Now see, as we minus this, we will get minus 0.01, right? We will get minus 0.01, but the minus sign indicates what? That it is decrease in concentration of reactant. Okay, or you can say that if you put minus here like this, so what will happen, that this minus and this minus, minus 0.01 and this minus would automatically cancel out, or we can say it is plus, right? So always remember that this is only for the decrease of concentration. Now calculate this value and its unit will be, now this is the concentration, that is mole per liter, right? And we are taking the time in minutes, so unit will come out to be minute inverse. So what will the value of this calculated by yourself? 0.01 upon 25 mole per liter per minute, right? Now second part of it, we have to calculate in seconds also. So what we have to do, this 25, this convert 25 minutes into seconds. So 25 into 60, as 1 minute is equals to 60 seconds. So 25 minutes is equals to 25 into 60 seconds. So now solve this and the unit will be mole per liter per second. Okay, now next in-text question. So this is the second part of the question, which I have converted this in seconds. Okay, now second question is that 2A, there is a reaction, general reaction in which 2A is a reactant and it will give product P. Now concentration of reactant is given, that it decreased from 0.5 mole per liter to 0.4 mole per liter. Mole per liter is the unit of concentration, right? In 10 minutes. Now what we have to calculate? Again we have to calculate rate. So apply the formula. So rate is equals to delta. Now reactant is A. So we will write it as A by del T. Right? Now I have already told you that if there is a stoichiometric coefficient here, then what will happen? That will be counted like this. That means denominator, or we will reciprocal it as we are taking for 1 mole, right? Now this is reactant, means concentration is decreasing, so minus. So now rest of the values are given, that is minus of half. Change in concentration is that 0.5 minus 0.4 upon 10, or remove this minus sign because this indicates, sorry, 0.4 to 0.5, final minus initial, 0.4 to 0.5. So as this indicates that reactant is decreasing in concentration. So now solve this by yourself. If the question is asked in minutes, then इस value को ऐसे ही रहने दो. If the question is asked in seconds, then convert it into 10 into 60 seconds, right? So this is the second part of this. So next we will do the next topic in the next lecture. Thank you.